We are live. We are live now. Hello, my dear friends. Hello, 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 hello. How are you? I hope you are all doing fine. First. Do tell me the do tell me the quality of the broadcast. Do tell me the quality of the broadcast. You have to rate it in between from 1 to 10. You have to rate it in between 1 to 10. If I'm audible, if I'm audible and the quality of the video is good, and if the video of the quality is good, you can rate it 1. If it is good and excellent, but it's okay, you can rate it 5 to 6. And if it is bad, you can rate it 1, 2, 3, however the way you like. After this, do tell me, how's the preparation of the exam is going on? How's the preparation of the exam going on? If it is going bad, you can rate it what? 1. If it is going okay, then you can rate it 2. And if it is going fine, excellent, very good, then you can rate it 3. 1, 2, 3. Whatever be the way you like, you can rate it 1, 2, 3. It is your what? It is your self reflection. 1, 2, 3. So you have to be real about it. How's the preparation of the exam of yours is going on? How's the preparation of yours exam is going on? After this. Yes. We have a. If your preparation is going on, you can say if it's going bad or if it is going okay. To make it to reach 3, to make it good, we have again come up with a very good plan. The plan, which usually cost 3,299 per month, now is it only 299 per month. 299 per month. Okay, only 299 per month. After this, okay. Where that thing gone? Oh, so we can make it to reach 3 for you. Sorry for the little disturbance that I had. Sorry for this. So we have a special plan for you. 3299 into 299 rupees per what? Per month. For that, you have to apply a promo code that I've written, NEET PHY30 and NEET PHY30, and you can get this very special discounts. 3299 per month? No, only 299 per month. Promo code NEET PHY30. This is the promo code that you have to apply to get this special offer. So today what we are doing? We are doing the Davisson Germer experiment. So this is going to be our today's topic. So little about me, myself, Raghav Sharma, 3+ years of teaching experience, MSc Physics, published an article in Journal of the American Ceramic Society, worked with the renowned researchers in Jawaharlal Nehru University, BSc from Delhi University, B.Ed from MDU. B.Ed from MDU. So this is about me. After this, our goal. Our goal for today. What is our goal for today? First, we have Davisson and Germer experiment. And then there is also setup for it. Davisson Germer experiment setup and how the whole thing works. Okay. And we have diffraction by crystal scattering, that is Bragg's law. So we have three things. Davisson Germer experiment that we are going to do today. We have Davisson and Germer experiment setup, and we have diffraction by crystal scattering, Bragg's law. With this we will complete our chapter dual nature of radiation. Dual nature of radiation. This is our goal for today. And if you haven't subscribed our channel on Telegram, make sure you do subscribe that. Make sure you do subscribe that. We have two channels actually. First is channel and another is chatting group. In chatting group, what can you do on it? You can ask, on those channels, we have Vishwajit sir, me myself is also present there, and we have also Pratyaksh sir also are there. So we all three are there. Our mentors are also there. So if you have any problems, any queries, whatever you want to ask, you can ask us on what? On Telegram channel. On Telegram channels. Any queries you have, any doubts you have, you can just ask us on what? On Telegram. We have channel and we have group also, in which we provide what? We provide PDF materials, we provide free classes, do various announcements related to the courses that are beneficial for you, and we do also provide discounts and various prizes. That you can get by just if you have subscribed our channels and you are on the groups. I am repeating again. You can, every faculty of the NEET are in the group. So you can just ask us anything on there. So let's start the thing. First thing. Let's start from the very start. First thing, de Broglie suggested that every particle has a wave associated with it. This means every particle has a wave. Okay, and that has given by the formula lambda is equal to h by p. For this statement, for this contribution, that Davisson de Broglie has got what? Has got Nobel Prize. He has also got Nobel Prize for this. So the lambda is equal to h by p. This is what the de Broglie suggested. Okay, and it can be written as like this: h p 2m k e, kinetic energy, and you can also write it as h upon 2m q v, where v is what? Applied potential difference, q is the charge, m is the mass, and 2 is 2, and h is what? Planck's constant. You know that na, k is equal to qv. Okay. So this is what our de Broglie guy suggested. Not suggested, he proved that also. This is the hypothesis, not proved. Proved is done by them. So after this, what happened? Davisson and Germer, those are the guy which experimentally proved that the electron can show what? Can show wave nature. Can show what? Can show the wave nature. It can show diffraction, interference, double slit experiment. It can show all the wave experiments that has done in what, in optics, that the electron can show what, can show wave nature. It can also show what, diffraction, interference, and all the experiments can be done by the electron too. Okay, this thing has done by what, has done by the, and showed by the what, Davisson and Germer. Okay, and he verified the JP Thomson, son of I think JJ Thomson. He verified the wave nature of electrons in when? In 1928. In 1928, he proved that thing. In 1928, okay. So JP Thomson verified this news, and he got what? He got Nobel Prize for that thing, and he got Nobel Prize for verifying that, So what we have first we have De Broglie suggested that every particle has a wave, and he has given the formula, and Davisson and Germer proved and experimentally verified that. Okay, So now we have done these things. After this, before going to the main thing, make sure you have subscribed our channel. For, we are always posting new things for the what, for our channel, and for you, we are always posting stuff about NEET. And that thing is important, okay, for you also. I think let's do the setup. For Davisson and Germer. What he has done, he has taken a coil. Okay, first these things, just see carefully. One coil, okay, one coil like this, and connected like this. Okay. This is a low tension current, low tension voltage in it, and voltage is in order of 6 volt to 12 volt. Okay, so battery is of low tension, and a current is flowing in it, So 6 volt potential we have created, and we have coated this thing, this coil, you can say, by barium oxide. Barium oxide has a very low work function. BAO, barium oxide. We have coated this coil by barium oxide, and barium oxide has what? Very low work function. If it is low work function, you can just you can do the emission of the electrons via very low potential voltage battery. You can do the emission via low battery, okay, low power battery. So we have done the emission. Now there is emission happening. From this coil. Then what we can do? Then there is a collimator. Here. Collimator. What is the work of collimator? Now this coil, the electrons are emitting in every directions. The electrons are emitting in every direction. In every direction. Okay, electrons are emitting in every directions. What is the work of this collimator? Is to make, you know, one is going this direction, one is going this direction. What this will do? This will do come here, be in a line, be in a line. Okay, so the work of this, to the electrons which are emitting from it, to make them in a fine line, to make them in a what, in a fine line. So there will be a what, a fine line of the electrons will become, a fine line of electrons will become. And this collimator is connected with a high tension battery, with a high tension battery, high tension battery, high tension battery. And this high tension battery is from, you can range its range is 40 volt to 80 volt, 40 volt to 80 volt. Now we have a stream of electrons. Now we have a stream of electrons. Now we have a stream of electrons. Now there is a nickel crystal here. Now we have a nickel crystal here. This is what? This is a nickel crystal. This is a nickel crystal. What will happen? So there is a stream of electrons is coming. Stream of electrons is coming. A stream of electrons is coming, and it is, if you know, what is the law of reflection? If something incidenting, it will get what? It is going to be reflected. So it is reflecting. This ray is what? This ray is reflecting. This ray is reflecting. Now here we have, where we have a you know, circular screen. Here we have a circular screen like this. Okay, like this circular screen. Okay, circular screen. So and we have a detector here. And detector is what? Detector is galvanometer. Detector is galvanometer. Detector is what? Galvanometer. That is sliding. That is doing what? That is sliding. That is sliding. That is sliding. So this is the what? This is the experimental set of what? Davisson and Germer experiment. I am going to repeat again. So here is the coil. Here is the coil. And there is a coating of what? Barium oxide, lower functions. The lower function. So we need a small what? A small, or you can say low tension battery to get a what? Thermo-ionic emission of electrons. Okay. So electrons are emitting in random directions. So to make a what? Electronic beam. To make a electronic beam out of it, we have a collimator here. Collimator. We have a collimeter here. Collimeter here. So because of this, a stream of electrons is becoming, and this stream of electrons is getting incident on what? Incidenting on nickel crystal. And from this, after reflection, there is a circular scale, and we are, you know, calculating at what angle. This is angle phi. This is angle phi. And what angle? What is the current that we are getting? And what is the various current at various angle? What is the various current at various angle? This is the what? This is the Davisson and Germer experiment setup. You know, simply in simple language. In simple language, we have this. In simple language, LANGUGE. In simple language, we have this. This is Davisson and Germer setup. In NCRT, we have this. Okay. In NCRT, we have this. In NCRT, we have this. In NCRT, we have this. So this is our what? This is our coil. This is our coil. And from this, electrons are emitting. This is our collimator, nickel target, movable collector, diffract electron beam. This is in the vacuum chamber. So this is in what? This is in NCRT. This is in NCRT. This is your experiment setup in NCRT. I think you have got it. I think you have got it. After this, let's see the working. Let's see the working. What is happening? What is happening? What is happening? Electrons are emitted from barium oxide coating of electrical heated tungsten filament. So what is happening? What is happening? What is happening? This is our tungsten filament and this is coated with barium oxide. Barium oxide has low work function. Has low work function. Has low work function. Because of this, electrons can be emitted with low tension battery. Electrons can be emitted with low tension battery. So electrons will get emitted from it. Electrons will get emitted from it. This electrons, this is first point. This is second point. These electrons are going to be accelerated through the collimator. This is the collimator. This is the collimator, and this is connected to the high tension battery. This is connected to the high tension battery. This is connected to the high tension battery. So the acceleration of these electrons will be what? Will be what? Force is what? Ma equal to QE. So the electric field, this acceleration will become A QE by M. So this is going to acceleration of this electron. Okay, they will come here and they are going to be accelerated. This electrons are incidenting on nickel crystal and are scattered in various directions. So they are scattering, okay, in this in various directions. And this is the movable, and this is the movable collector. This is the movable collector that is reading how much electrons are getting emitted at various angles. At various angles. Okay. The reading of the galvanometer, the reading is directly proportional to what? The particular angle and the tension of this battery. So how much big the reading in galvanometer is proportional to what? Is depending upon what? Is depending upon the angle. This angle is phi. This angle is phi, not theta. This angle phi, and the potential applied. So this theta, this reading in the galvanometer is depending upon what? Is depending upon the angle phi and depending upon the voltage of the galvanometer. So this voltage of this galvanometer. So this on two things, this thing is depending upon. After this. Okay. So what we have seen, the best thing is happening. The best thing is happening on between 44 voltage to what? 68 voltage. So we are getting best result in this range, 44 to 68. How we are getting this results, and why we are saying these results are bad, these results are best. In this range, we can see what? We can see constructive interference pattern. Constructive interference we can see in this range, in 44 to 68 voltage. Constructive interference is the phenomena of what? Is the phenomena of wave nature. In optics, we do na in optics. In interference, constructive interference, destructive interference. This is the same thing we will see on this range. We are seeing the same thing on this in this range. Okay, how? Let's see. First, draw this graph. Let's draw this graph. 44 to 68. This is the graph element I, current in galvanometer, and the angle phi. And let's say this graph is for 44 voltage. 44 voltage. We will see graph like this. We will see graph like this. At 48 we will see graph like this. At 48 this is for 48 voltage. 48 voltage. We will see a more sharp, okay, not that much also. We will see more sharp. Okay, and at 54 we will see graph like this. Okay, we will see graph like this at 54 voltage. At 54 voltage we will see graph like this. Okay, this is the graph we will get for what? For the diffraction pattern, very close to diffraction pattern, or you can say similar to diffraction pattern. This is the same diffraction pattern we will see in wave nature of particle at the 54 voltage. This is the same thing. This is the same thing we will get at what? At the diffraction pattern. And diffraction pattern is what? Is the wave nature. And you will see, and what are you seeing? What you are seeing? You are seeing the what? Electron scattering. You are seeing the electron scattering at various angle. And here and here and here. Means at some angle, at this angle, this angle where the peak is coming, this is around 50, okay, this angle is 50 degree. So at 50 degree, at phi equal to 50 degree, what we are seeing? It's saying the maximum number of, or the majority of the electrons are getting refracted at the angle what? At the angle 50. At the angle 50. And now let me tell you one thing. Okay. Now let me tell you one thing. It will just blow your mind up. Okay, blow your mind up. And from this statement, we will enter on the realm of quantum mechanics. We will enter the realm of what? Quantum mechanics. Imagine there is no beam of electron. There is only a single electron. Only a single electron. What? Only single electron. If it is going to be, go in this thing, it will going to be show you the same graph. Single electron is also going to give you the same graph, I into phi. This electron is behaving like what? Is behaving like a what? Like a wave. You know, when you do the quantum mechanics, there is a formula like this called Heisenberg uncertainty principle. No, this is not in a syllabus, but very interesting things. Heisenberg uncertainty principle. Del x del p is also going to be greater than h cross 2. If you know the position, you can't know the momentum. If you know the momentum, you can't know the you can't know the if you know the correct momentum. If you know the correct momentum, there's going to be uncertainty about the where it is going to be. And if it is if you know the correct position of the particle, there is always going to be uncertainty about its what momentum. Del x del p is greater than h cross 2. So from here we will enter the realm of what? Into the realm of quantum mechanics. And for this they got what? They got Nobel Prize. For this they got what? They got Nobel Prize. You know, all the scientists that you are studying in 12th class, almost every one of them has the Nobel Prize. They all have what? Nobel Prize with them. So all has done tremendously in their respective fields. So this is the actual graphs. Okay, actual graphs by the experiment, and they are the actual graphs. The actual graphs they get for the I and phi. These are the actual graphs for 40, 44, 48, 54, 60, 64, 68. So this is the actual graphs they get on the experiments. You can see on the 50 degree they are getting a peak, and the peak is very significant at the V equal to 54 voltage. And it's significant at what? Significant at 54 voltage at theta equal to phi equal to 50 degree. Phi equal to 50 degree. This is very significant at what? At the 54 volt. At the 54 volt, that thing is very much significant. Okay. This is the what they have gotten by the experiment. Diffraction by crystal scattering. This is the result the Davisson and Germer actually got. Okay, RESULES. These are the results they actually got. At 54 volt, peak is very significant at phi equal to 50 degree. At phi equal to 50 degree. Okay. So V is 54 volt and phi is what? Phi is 50 degree, and phi is 50 degree. Okay, and this is showing what? This is showing constructive interference. This is showing what? Constructive interference. And what is the condition for the constructive interference? Okay, the path difference is going to be like this: 0, lambda, 2 lambda, and 3 lambda, and so on. Okay, this is going to be the path difference. In this case. Okay. This is for this. Now see diffraction by crystal scattering, Black's law. What these things say? This is the result we have gotten by the wave nature of electron. This is by the wave nature of electron. Okay, this is the wave nature of electron that the thing showed. But actually we have done this what? We have done this by the particles, by the electrons. Okay, now let's do the actual calculation. So let's go interatomic. Let's go what? let's go interatomic, dude, let's go interatomic. So let's make some electrons, let's make some layer. Okay, let's make some layer like this. Say this is our nickel crystal. This is our what? Nickel crystal. This is our nickel crystal. This is our nickel crystal. Nickel crystal. This is our nickel crystal. And this thing is happening, and a beam came and reflected like that. And this angle is what? This angle we have as is phi. This angle is phi. This angle is phi. This angle is phi. Okay. Okay. Are we clear? Are we clear? Now let's say a parallel beam. Okay, we are talking about beam. So another thing is coming. Another thing is coming like this. A beam. We are talking about beam now. Beam is not a single line. Done and gone like this. Another beam, another beam, another beam, another beam. Okay, and this is our layer. This is our layers. This angle phi. So this is angle, this angle, this angle, this angle. Brake's law is concerned about this angle theta, the angle between the layer and angle between the incident beam. This is the what our Brake's law is concerned about. Let's say if we take a bisector, perpendicular bisector like this. This phi will become phi by 2 and phi by 2. We are doing the derivation of Brake's law. This thing is important. Okay, phi by 2, theta. Let's make a perpendicular bisector here and like this. Now this path, let's name things. Let's say this is x, let's say this is y, let's say this is z. So the path difference or the extra path that thing is taking is xz plus yz. This is the extra path this thing is taking, means this path. This path is what? Path difference. This path is path difference. Okay, this is path difference that we want to find, the extra path. And on this thing the diffraction pattern depends. Okay, on this thing the diffraction pattern depends. If this is theta, this is 90, this is 90. Now this is also going to be theta. How? This is going to be theta. This is going to theta, and this will become 90 minus theta. This will become 90 minus theta. 90 minus theta. If you don't know this thing, why this is become theta, this is 90 minus theta. My dear friend, you are in a dire need of what? You are in dire need of trigonometry. If you don't know how this thing has come 90 minus theta, how this came, this 90 minus theta. Okay, if we see this thing, this thing, theta plus phi by 2 is what? 90. This angle is 90. This is 90. So theta plus phi by 2 is 90. Now let's say what is theta? Theta for this. Okay, theta for this. Phi we know is 50 degree. So theta will become 90 minus phi by 2. So 90 minus 50 by 2 for this result, and this will become 90 minus 25, 65. Theta is 65 degree. Theta is what? Theta is 65 degree. Okay, theta is 65. Theta is 65. And delta x is delta x, delta x, delta x, delta x. Delta x is xz plus yz, xz plus yz. Okay, xz plus yz. This is theta, this is 90 minus theta. So xz, this thing will be by the trigonometry, this thing will be, and say this separation is interatomic step separation is d. This thing is d, this thing is d, this thing is d. So xz will be d cos 90 minus theta. Xz will be d cos 90 minus theta. D cos, see what is the cos 90? Perpendicular upon hypotenuse. Perpendicular xz, hypotenuse. Hypotenuse is what? This ZOD. So Z, so you can say, let's make this here. Okay, let's make this thing here. This is 90. This is 90. This is D. This is 90 minus theta. This is 90 minus theta. What will be the cos 90 minus theta? What is cos? What is cos? Base upon hypotenuse. What is base? This is base. This is base. Base is xz. Hypotenuse d. So xz will be d cos 90 minus theta. This will be d cos 90 minus theta. Okay, my dear friends. Okay. So this is d cos 90 minus theta. In a similar way, this thing also, zy is also d cos 90 minus theta, is also plus d cos 90 minus theta. What is cos 90 minus theta? What is cos 90 minus theta? Cos 90 minus theta is sin theta. Cos 90 minus theta is sin theta. This this thing will become d sin theta plus d sin theta, and this thing will become 2d sin theta. 2d sin theta. Path difference will be 2d sin theta. 2d sin theta. And delta x for the interference diffraction is n lambda. N is the number of the maxima. For the first maxima, n equal to 1. For the second maxima, n equal to 2. So this thing will become n lambda equal to 2d sin theta. 2d sin theta, delta x equal to n lambda 2d sin theta. Important. Okay, important. And this formula is also important. This thing is also important. This little is also important. This relation is also important. So these two formulas, the relation between theta and phi, theta plus phi by 2 equal to 90, and this formula delta x equal to n lambda equal to d sin theta, this thing is also important. So you should remember these two things. Okay, you should remember these two things. We now know that 2d sin theta is equal to n lambda. Now we are talking, now let's compare for nickel, NaCl, for nickel. We know the interatomic separation is 0.91 angstrom. D is this. So we can write this as 0.91 10 raised to minus 10 meter. And we know that theta is 65 degree. Theta is 65 degree. For first maxima, okay, just see for first maxima, lambda will be, wavelength will be 2, and d is this 0.91 10 raised to minus 10, 10 raised to minus 10, 10 raised to minus 10, and sine 65. If we put the value sine 65, the wavelength we will get is what? Is 1.65 angstrom. Is 1.65 angstrom. 1.65 angstrom. And if we calculate for 54 voltage, okay, 454 voltage lambda, by the de Broglie for the 54 voltage, in which we are having what? In which we are having diffraction pattern. Okay, and that is what okay, that is what. Now let's do it in different page. Let's do this in different page. So lambda is what? H by P, or we know it is H by 2 mk in terms of kinetic energy, 2 mk, or you can say H upon 2 m qv in terms of potential difference, and for electron I have told this lambda can be written as like this: 150 upon v, where v is potential difference, or we can write it as like that, like this: 12.27 upon v. 12.27 upon v. And if we apply 454 volt lambda, 454 volt lambda, 454 volt, okay. 454 volt. So lambda will be 12.27 under root and 54, and the value we will get is 1.67 angstrom. This is by the de Broglie. We get, and this is and 1.65 and 1.65 by the wave nature, or by the diffraction, by the Bragg, by the wave nature, or you can say by the Bragg's law, So that's how our friend, not my friend, not your friend too, that's how Davisson and Germer proved and have got a Nobel Prize, and proved the hypothesis, and laid the foundation for what? For the quantum mechanics. And later many scientists showed also interference, polarization, or you can say polarization, and also this thing for neutron, for proton, for the ionized atoms, or for the heavy molecules too. So this thing proved for all. This thing has gotten proved for all the molecules. That we have in existence. That's how this thing has come into your syllabus. That's how this thing has come into your syllabus. Actually very important stuff, actually very important thing. If you see how this thing laid the foundation for various things, for the various subjects, that students do read in higher studies. So this is the starting point for all those things. This is the starting point for all those things. If you see, so this is the foundation thing. This is the foundation thing. Foundation things. Now let's talk about our question. 2011 question. NEET 2011. NEET 2011 question. Okay, we have done so much theory, so we are doing only one question. So the question is actually I have already told you the answer in the theory. If you have watched the lecture, you will know the answer. In the Davisson and Germer experiment, the velocity of electrons emitted from the electron gun, velocity from the electron gun can be increased by increase the potential by first A option, increasing the potential difference between the anode and filament, by B, increasing the filament current, C, decreasing the filament current, or D, decreasing the potential difference between the anode and filament. What will be the answer? If you increase or decrease the filament current, what will happen? What will happen? Intensity will go increase or decrease, but it will do not have any effect on what? It will do not have any effect on the velocity. So B and C are wrong answer. Okay, current is running on what? Current is running on the current is running. So let's see the again. Let's see this diagram. Okay, this diagram, just see this again. If we increase the current or decrease the current, this filament we have, okay, this is connected to the low voltage battery. So if we increase the increase the current, what will happen? Number of electrons emissions will increase or decrease. Number of electrons, okay, number of electrons, or we can say intensity. Number of electrons but if we increase or decrease the what? This voltage, okay, this voltage is, what is the formula? Formula was kinetic energy is equal to the Q into V. So this voltage is directly proportional to the what? Kinetic energy. If we increase the voltage, charge is constant, so kinetic energy will increase. If kinetic energy increase, then what will happen? Velocity will increase. The velocity will increase. So the correct answer is A, increasing the potential difference between the anode and the filament. This will increase the what? This will increase the velocity of the electrons. And if we decrease the potential difference, the velocity is going to decrease. Then the velocity is going to decrease. After this, our course has 90 plus classes, concentrated and concise lesson plan. Okay, concentrated and concise lesson plans that you need for clearing the NEET exam. 90 plus classes, concise and concentrated, and we have convenient education platform. You can access it from from every platform. You have laptop, you can access it. You have PC, you can access it. You have mobile, you can access it. You have tablet, you can access it. You have iPhone. The fun fact is, if you have internet, then you can access us from everywhere. You can access us and access our course from everywhere. Syllabus from NEET experts. Syllabus from NEET experts. This course, or this thing, this syllabus and this course is made up from the NEET experts. Me, Vishu sir, Pratyaksh sir, and our SME team, and the team that are sitting. We made this course. Okay, we made this course by sitting in the office for hours. So we have done so much thing for you and waiting for you. Come and take it from us, and get out and get a rank, and get a good rank, and go into your dream college. We have flipped classroom method. We have what? We have flipped classroom method. This is the thing that we are introducing fast in all over the India. In all over the India, this is the thing that we are introducing, flipped classroom method. Most unique thing that we have. This is the thing that you should experience by yourself, and how good it is. Okay, if you're taking the class from this flipped classroom method, you will have a 40% more chance to excel your preparation and get yourself a good score. And we also have doubt solving practice. We call them DPPs, daily practice problems. We have from you. The problems that are actually focused on what? On the course. We are here for your preparation. Okay, we are here for your preparation to get you into your in a good college. We are not here for impressing. We have all the things that is necessary. Not low, not high. The thing that is necessary and must in a NEET course. After this is our class looks like. We have theory, we do the theory, we complete all the thing. Okay, and we do some questions on this segment 2, in the theory segment 2. Okay, that questions are necessary. Then we will provide you study material, and we have a doubt solving session, webinars on the same topics. If you have some doubts that you want to clear, that we can clear your doubts in the webinars. Then there are homeworks. We provide you homework. Okay, and we do also check them. And if you are not going to do that, and if you forgot to do that, okay, then there will be a call to your parents, and they and us are going to scold you that if we are doing that much for you, then why can't you even do your homework? Then why can't you do even your homework? If we are doing this much for you, homework you should do na. Homework you should do. Not a big thing. Okay, so we have 3 plans for you: light, smart, and proficient. This 4 thing: interactive live classes, live sessions, course and PDF, structures course and PDF, live test, physical notes, are all in the are all is also in light, is also in smart, is also in proficient. What smart and proficient offer more is one-to-one mentorship. Okay, when you get lost somewhere, when you want to reach somewhere, what do? You open your phone, okay, in a location where you want to go, and let do the maps do his work. The same thing mentorship does. It helps you to reach your destination, and destination is what? White coat and a stethoscope and a doctor degree. We also have live doubt solving thing. Again, that thing is necessary. If you have any doubt, If you have any doubt, okay, sir, I can't solve this, just send us the thing, send us the question, send us the doubt, and we have the faculties sitting in the chats that going to solve your question at the very spot, at the very, at that time also. Okay, at the same time they're going to solve your what, your doubts, your questions, the, the queries you have. And we have mock tests regularly. Mock tests are important. Okay, in how much water you are in how much water you are in, you know, to check the reality, to check the reality. Okay, reality check is important. Reality check is important, my dear friend. Reality check is important. Okay, you should not lie about yourself, that where are you standing right now, and this thing show your reality check, and does reality check where you are. And in start I always ask, how's the preparation going on? 1 2 3, one bad, two okay, okay, three very good. So this thing does these things if you are in one segment, or in two segment, or at the third segment. And in proficient we have additional special courses for your motivation. If you want to get the motivation from various faculties, you can have the, you can have that motivation also. We have that thing on proficient course. We have that thing on proficient course. And all that and all that thing, if you want to enroll all that thing. Yes, my dear friends, you are seeing it right. All that thing you can get only and only and only and only in 299 rupees per month. You can get that much. Yes, you can get that much only at 299 rupees per month. You don't have to pay 3299 per month. You only have to pay 299 rupees per month, and you can have that all. And you can have that all. Live classes, structure scores, live test, physical notes, mentorship, live doubt solving, mock test, all that things only in 299 rupees per month. For that, what you have to do? You have to apply a promo code, that is NEET PHY30. Apply this code, and this plan you can get in 299 rupees per month. Yes, you are hearing it right. Only at 299. Only on 299 you can get this course. Yes. So what are you waiting for? So we have two classes. So we have two groups on Telegram. The useful file you can get and the announcements on this channel, on this channels, and the chatting group that we have, that I am in, that Vishwajit are in, that Pratyaksh is in, is on this. This is our discussion group. This is our discussion group. Come here and have a chance to talk to me, talk to Vishwajit sir, talk to Pratyaksh, talk to our talk. Get a chance to interact with our faculties and our mentors. You don't have to pay anything. You don't have to pay anything to get on this, channels. Okay, कब मिलेगी? To get on these channels, you don't have to approve Mitra. Okay, so this is what we have. Okay, this thing is absolutely free. You don't have to just scan this, and you can get in our channel or in our group, discussion groups. So see you, my dear friend. See you, my dear friend, tomorrow. See you, my dear friend, tomorrow in the new lectures, in the new series. Till then, take care of yourselves. Take care of yourselves. Be happy and do study. Okay, do consistently. Okay, consistency is the key to get your dream college. Bye.